Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and hi to everyone. My name is Abdul Muiz bin Muhammad Nasir and I am from section 2. Okay, today my friend and I want to show to all of you about how to do simulation based on the exercise 2, which is power in AC circuit. Okay, first I want to tell to all of you, we use the Proteus design suite 8.9 to do the simulation. Okay, for your information, I will show to you about how to do simulation based on the activity 1. Okay, this is the circuit for activity 1. Okay, before that we start to click new project at the Proteus. We click next until this finish. Okay, this is my Proteus and this is my circuit. Okay, for the first step we see this circuit, it has AC source, so we can find AC source from this Proteus, add component from libraries and just type AC source. Okay, this is my AC source. We click here. Okay, and the second step, we see the value at the AC source. It is the 100 VRMS, so we click AC source to put the value here. Okay, the value, it is the amplitude value. Okay, for our information, for our theory, the amplitude value is equal to VRMS times Z2. So we use calculator to calculate that Z2 times VRMS, which is VRMS is 100. Okay, Z2 times 100, it is 141.42. So we put here 141.42 for amplitude. Okay, the frequency, it is 50 Hz, so just change it is 50 Hz. Click OK. Okay, next, from our circuit, it has resistor, right? So we find the resistor at the same place component from libraries. Resistor, we spend resistor here and it's display resistor here. We put it here. Okay, and then I rotate that because my circuit, the resistor at perpendicular, right? So next step, same, we change the value first. Okay, for the value, okay, based on this table, the first value of resistor is 210 ohm. So we click here, we change the value 210 ohms. Click OK, and next we see the circuit, it has wattmeter. So at wattmeter, we can get from the instrument. It is wattmeter. We click and we put it here, and last we put it ground. We can get ground from the terminals. Okay, this is ground. Okay, we click here. Okay, next step, we can connect the wire. Okay, before we connect the wire, I want to describe a little bit for wattmeter. Okay, this is the what we call line for current. Okay, line for ammeter. So we need connect line for ammeter in series. So we click here. So this we can put here. And last, okay, this is the polarity which is line for wattmeter, and line for wattmeter we must connect parallel with the resistor. Okay, parallel with this resistor. Okay, finish. Okay, before that, we want to find the power which is in unit watt. So we must change the wattmeter in unit watt first. At here, watt in watt. Okay, click OK, and then next step we run this circuit, and okay, it show here it is the value of resistor, the value of power in watt. So this the value of power is 47.6. Okay, first we can add here 47.6. Okay, it is for 210 ohms. Okay, next we do at the number 2, which is resistor is 390 ohms. So before that we click to stop run, and click here to change the value. Okay, the second value is 390 ohms. So 390 ohms. Just click OK and run. Okay, the value of power in watt is 25.6. Okay, click the second value is 25.6 watt. Okay, next the number 3 is for 470. Okay, first we need to stop and click here, change the 470 ohms, 470 ohms. Click OK and run. .3. Okay, the value of power is 21.3. Okay, 21.3. Okay, next we must to stop the run first, and and number 4 is 860. Okay, we need to change the value 860 ohms. Put okay, we can run. The value of 860 ohms resistor is 11.6 watt. So we click here. Okay, 11.6 watt. Okay, we center this value. Okay, next for number 5, it has two resistors in series because it is plus here. So in this Proteus, we stop first, and we must add the one more resistor. Okay, from libraries we find one more resistor, and we put it here. First we must delete the wire, this wire, and rotate it. Okay, just put it here. Okay, we change the value. Okay, R1 is 210, 210, and the second resistor is 470. Okay, okay. Okay, we connect wire. Okay, this is the circuit in series. We connect the resistor in series, which resistor one is 210 ohm and the next resistor is 470 ohms. So we run. So the value of power is 14.7 watt. 14.7 watt. So we write here 14.7 watt. Okay, we enter that value for. Okay, next for number 6, it also series 210 ohms and 860 ohms. So we we must stop first and edit the value for second resistor because this is the different value, which is 860 ohm. Okay, the first resistor is 210 ohm and the second resistor is 860 ohm. Okay, we have checked and run. Okay, the value of power is 9.34 watt. Okay, we click here. 9.34 watt. Okay, oops, just enter the value 9.34 watt. Okay, next. Okay, if we see the number 7, it also have add resistor but in parallel, so we must change the circuit. We must edit. We must click here and I want to delete this and put a new resistor. Okay, put the new resistor here and rotate it. Okay, for the resistor in parallel, right? So we must sorry. Okay, I want to make sure the wire is connected at the right position. Okay, settle. So second step, we must change this value. Okay, the first value is 210 ohm and the second value is 470 ohm. Just click here and change the value 470 ohms. Click OK. Okay, we check first before we run. First, resistor is 210 ohm and second resistor is 470 ohms. We run. Okay, the value of power is, what is that? 68.5. Are you sure? Okay, sorry, 68.9. Okay, the value is 68.9 watt. Okay, we center this. Okay, for the last step is we change. Okay, it is in the also parallel, but the second value of resistor is 860, right? So we need to just change this value with 860 ohm and click OK, and we start to run with the same step. We can get the value of power is 59.2 watt. So we click here, the last power is 59.2 watt. Okay, this is the simulation for activity 1.
So I'm gonna be simulating for activity 2, which we need to simulate it to get the value of Q, which in unit of var using different load, which is R plus L. So the circuit is like this. So the AC source is in VRMS, which is 100, and the frequency is fixed to 50 Hz. So by using software, Proteus software, so I've already picked the component in advance to save time. So alternator is an AC source, and then we have resistor in series with inductor. So the first value is 210, and inductor value will be 0.4. So we need to change this into series. So by picking our instrument, we're using wattmeter, and then so I'm gonna connect all the wire. So the first wire will be connected to the supply, and this current from wattmeter is connected to this series of resistor with inductor. So this one is connected to the supply. This polarity is connected to this, and this is connected to this. So another component is ground. So I'm going to be adding it here. Ya Allah, go for terminal. Okay, terminal. Okay, ground. So change any. Okay, change any to 141.42 because 100 VRMS is we convert it to V. We need to multiply by sec2. So the frequency fixed to 50 Hz. Valid expression. change anything. So yang ni kita nak calculate dalam var. So var, and then dah siap, kita run. So kita dapat yang first value adalah 21. Okay, 21. And then the second one, kita kena tukar yang inductor, which is into 0.8. Tukar 0.8. And then run. Dapat 23.5. 23.5. So the third one is 1 Henry. Stop. Tukar yang ni to 1. Okay, then run. We get 22. So 22.0. So the third one is 860 plus 0.4, where the resistor is a constant with the value of 860. So stop, change the resistor to 860. And then, so we're gonna do for Henry 1 first. So run. We'll get 3.75. 3.75. So 0.75. So the next one is 0.8. 0.8. So stop. Change this one. 0.8. And then run. .14. 3.14. The last one is 0.4 Henry. Stop. Repeat the same process. Tukar ni 0.4. Okay. And then run. .67. Sekejap. So stop. Run again. 1.67. 0.67. So that's all.
Okay, first I'm gonna start with AC voltage source. Next, I'm gonna have to get resistor. I'm gonna rotate it, and then capacitor. And then the ground. And lastly, wattmeter. I'm going to connect it. For current, we connect it in series. For voltage, we connect it in parallel with the load. Okay, I'm going to change the voltage source to be 141.42 volt. And the frequency is 50 Hz. I'm going to change to VAR, which is reactive power. R would be 210. and capacitor would be 2 micro. I'm gonna run it and I'll get 6.17, 6.18. Okay, and I'm gonna repeat it until all the load is finished.